Hello students. Today we are going to talk about an important topic. How to deduce formula of ionic compound. Chemistry can feel like a puzzle, but once you know how the pieces fit together, it's actually quite logical. Deducing formulas is just a fancy way of saying, figuring out how many of each atom you need to make a stable compound. Here's the step-by-step breakdown. 1. Understand the goal, the zero charge rule. The most important rule in ionic chemistry is that the total charge must equal 0. Think of it like a seesaw. If you have a +2 charge on one side, you need a -2 charge on the other to keep it balanced. Now another important question is how to find charge on an element. To find the charge of the ions, you need to know the group of an element in periodic table. Elements present in group 1 have always +1. Group 2, always +2. Group 13, always +3. Group 15. Nitrogen and phosphorus, usually -3. Group 16, oxygen and sulfur, usually -2. Group 17, always -1. Now we will learn the compound ions. Sometimes atoms stick together in a group and act like a single unit with one charge. Treat these like a single block. For example, hydroxide, OH-, sulfate, SO42-, nitrate, NO3-, carbonate, CO32-. Now, the best and easy way is swap and drop method to write a formula. Let's try making magnesium chloride. Number 1, write the symbols and charges. Magnesium is group 2, so it's Mg2+. Chlorine is group 17, so it's Cl1-. Now swap the numbers, ignore the +- signs. Number 2, take the 2 from magnesium and give it to chlorine. Take the 1 from chlorine and give it to magnesium. Number 3, write the result as subscripts. Mg1Cl2. Number 4, clean it up. We don't write the number 1 in formula. Final formula is MgCl2. Now we will learn formulas by using compound ions. For compound ions, you must use parentheses. For example, magnesium nitrate, Mg2+ and NO3-. Swap the 2 to the nitrate and write formula MgNO3 whole twice. This means you have 2 whole nitrate groups. Now, what about the middle of the periodic table? I mean the transition metals. Think of transition metals like iron, copper, or gold as the chameleons of chemistry. Unlike the elements in group 1 or group 2, which always have the same charge, transition metals can change their personality depending on what they are reacting with. They have a multiple personalities problem. In the main groups, the rule is strict. Magnesium is always +2. It never changes. But iron is moody. Sometimes it shows up with a 2+ charge and becomes iron 2+, and sometimes it shows up with a 3+ charge and becomes iron 3+. Because of this, we cannot just say iron chloride, because nobody would know which version of iron we are talking about. So, what is the solution? Scientists use Roman numerals to avoid confusion. These Roman numerals tell us exactly how many positive charges that specific metal has in the compound. For example, iron 2 means +2 charge. Iron 3 means +3 charge. Copper 1 means +1 charge. Copper 2 means +2 charge. Now let's write some formulas. First example, iron 2 chloride. This uses iron 2+. Chlorine has a -1 charge. To balance the charges, we need to swap 2 from iron to chlorine atoms, and 1 from chlorine to iron, so the formula becomes FeCl2. Now let's look at iron 3 chloride. This uses iron 3+. Again, chlorine has -1 charge. This time, we again exchange their charges. So the formula becomes FeCl3. Even though both compounds contain iron and chlorine, they look very different. One is usually pale green or white, the other is dark orange or brown. Now let's take another example, copper 2 sulfate. Step 1. The name says copper 2, so the charge on copper is +2. Symbol Cu2+. Step 2. Sulfate is a compound ion with a -2 charge. Symbol SO42-. Step 3. Balance the charges. Copper has 2 positive charges. Sulfate has 2 negative charges. Because the charges are equal, they balance perfectly in a 1-to-1 ratio and charges cancel each other. Step 4. The final formula becomes CuSO4. Now let's summarize. Whenever you see a transition metal in a compound name, number 1. Look at the Roman numeral. That tells you the positive charge. Number 2. Ignore the group number of the periodic table for these metals. The Roman numeral is what matters. Number 3. Apply the swap and drop method, just like before. And that's how transition metals work.